So dear students, hope all of you doing good. So let's move on to the next one. And before we move on to the next Peterson algorithm in the synchronization, so there is a small announcement. So I have made small mistake while writing the question. In the round robin scheduling, I have given the homework for you. So in the homework, this is a question given to you, and I said these are the answers. So some students sent me a mail that okay, answer is not matching. So actually I wrote the mistake in the question. So here, okay, make the correction. So here, okay, I said 8, I have written 8, but remember this is not 8, okay, so this is not 8, this is what, 2 here. So 8 nahi hai, ye 2 hai. Is that clear? So please make this correction, and if you solve again, so this is the answer you should get. Okay, so please check properly. I think this is in the lecture number 3, or I think you are following, so obviously you will know that. So in the round robin, the homework I said, I gave you the homework. So in the question, yahan pe mai 8 likha tha, so change it to 2. Is that clear? Right. So that, okay, please make the correction. Next. So let's move on to the next one. In the previous session, okay, we were discussing the solutions, okay, in the synchronization. Hope all of you following the lectures. Okay, in the previous session we were discussing, okay, solutions part. Okay, we have seen lock variables and also Peterson algorithm. Sorry, lock variables and strict alteration. Okay, and we have seen some important points also. Okay, I am assuming all of you following the class and revising the notes properly. So next, continuation, we will move on to the next algorithm. So that is Peterson's algorithm. Peterson's algorithm. Okay, so note down. So copy the, okay, what is the algorithm says, and please copy this. So I'm going to write here. Okay. Hash define ns2 hash define true as 1, hash define false as 0, integer turn integer interested of n. Please copy the solution algorithm what is given, and next void enter region integer process, void enter region integer process, integer other, other equal to 1 minus process, interested of process equal to true, turn equal to process, while turn equal to process and interest of other equal to true, then you have semicolon. Okay, while turn equal to process, okay, this is a and double ampersand, and interest of other equal to true, so then okay, semicolon there. So then you have a critical section, void leave region integer process interested of process equal to false. Copy this, and next copy this also. Initially interest of 0 is false. Interest of 1 is also false. So this is given to you in the question. Okay, so no need to worry about that. And next copy this also. Process will take two values, 0 or 1. So process 0 means process value 0 means you are representing process P0. Process value 1 means you are representing P1. Okay, if it is not visible, you can zoom that. Okay, I think you can zoom, anything is missing. So anyway, I am okay, explaining verbally also, orally also, right. So process will take two values, either 0 or 1. So 0, if you take process values, means you are playing P0, and 1 means P1. So copy this. I am just going by side. So please pause my video and copy everything on the board. पास करके वीडियो बोर्ड कॉपी करो पूरा. Right. Okay. So next understand here. Okay, if anybody not copied, pause करो वीडियो. Okay, पूरा कॉपी करो अच्छे से नोट्स में, उसके बाद ही okay continue करो. So let's move on to this. What is the meaning of Peterson algorithm? Okay, let's try to understand. So in the braces, यहाँ पे लिखो Peterson algorithm. So it is a two process solution. Two process solution. Okay, just note down this. Braces में लिखो. So it means what? The solution works only for the two processes. Solution works only for the two processes. Listen everything carefully. So this is very interesting and also important. There are so many questions based on only this algorithm. Okay, so listen here. So in this we are having only two process. Solution works only for the two process, and process value takes either, okay, in this we are using a variable called process. In the algorithm we are using, okay, integer variable called process. So the process, okay, it will take two things, either 0 or 1. Okay, integer variable hai, process integer variable hai, it takes two values, either 0 or 1. So if the process value you take as 0, it means you are representing what? P0. If you take process value as a 1, you are representing P1. Okay, so that is the meaning of the process. And next, understand here, okay, this is the code given to you. We are having common critical section, and what we are trying to do, हम लोग करना क्या चाह रहे हैं? Okay, we are having common critical section. Critical section means what? Share variables, share resources. Now, okay, both the processes, that is P0 and P1, are trying to access the common critical section, and we are trying to provide synchronization to the processes to access the common critical section. Okay, right. So now we need to do the analysis and understand, okay, whether it is a correct solution or incorrect solution. So when you will say it is a correct solution, if it is following our conditions, okay, like for example, mutual exclusion, progress and bounded weighting. So if it is following that conditions, then you will say it is a correct solution. If it is not following that condition, you simply say that is a, okay, wrong solution. Okay, is the point clear for everyone? Right. So now I will just go to the code, okay, and I will explain the analysis. So just listen carefully. Hash define n as 2. Listen here. So hash define n as 2. Okay, hash define, I think all of you know. So n value you are just defining with the 2. Okay, it means wherever you have n, it will replace with the 2. That's it. So next, hash define true as 1. Okay, hash define true as 1 and hash define false as 0. And next, okay, integer, okay, you are defining, okay, true with the 1 and false with the 0. I think all of you know this. So integer turn, look at here. So integer turn को ऊपर declare किया. Turn is a shared variable. Turn is a shared variable used by both the processes P0 and P1. दोनों के लिए सिर्फ एक ही variable है. Turn is a shared variable used by both the process P0 and P1. Okay, so note down, make a note of this, note down properly. Turn is a shared variable used by both the processes P0 and P1. Turn is a shared variable used by both the process P0 and P1. Okay, right. So next, now understand here, integer interested of n. Now tell me, integer interested of n. So what is the n value you have? 2. N value is 2. So integer interested of 2 here. Okay, so array, it is an integer array, simple. Okay, integer array index start with what? 0. So it means what? Interest of 2 hai, so it means what? Interest of 0 hoga and interest of 1. Interest of 0 and 1. Remember, initially both are assigned to what? False. So interest of 0 is also false and interest of 1 is also false. Okay, so that is already given in the algorithm. You cannot change these values. Initially the values always interest of 0 is false and 1 is false. So that is given in the algorithm. Next, void enter region. So this is the code used by the process to enter the critical section. So void enter region, it will execute this. If everything is fine, it will enter into critical section, and while leaving, you are executing what? Leave region code. Leave region, interest of process false. So now listen here, void enter region integer process. Now tell me, what is the process value? Process value can be what? Either 0 or 1. So you have only two options. So process value can be two things, either 0 or 1. So if you want to execute for the process P0, so you have to take process value as what? 0. If you want to execute for the process P1, you have to take process value as 1. Okay, so now understand here. Next, integer other. So okay, look at here. So whatever you take, for example, if I take process value as 0, it means you are representing what? P0. Anything you can take. So integer other. Okay, other is a local variable here, and other equal to 1 minus process. Listen here, other equal to 1 minus process. इसका मतलब क्या होता है? What is the meaning of this? If the process value is 0, the other becomes what here? 1. So at 1 minus 0. 1 minus 0 is what? 1 only. So it means what? Okay, for the process P0, other will be what? Process P1. Now if you take process value as a 1 here, okay, now tell me, if I take process value as 1, what the other becomes? Other becomes 1 minus 1, that is 0. So it means for the process P1, the other will be what? 0. So if it is P0, so other P0 के लिए other P1 होगा और P1 के लिए other क्या होगा? P0 होगा. समझ में आया? Right. Okay. So next, okay, interest of process equal to true here. Interest of process equal to true. Understand here, interest of process. Interest of process initially both are what? False here. Initially both are false. Okay, and next, interest of process को क्या कर रहे हैं बताओ? True कर रहे हैं. So when the process is trying to enter into critical section, okay, you are changing the interest of process equal to true. And the turn equal to process. Understand here. Okay, so turn equal to process. Understand here, process value will be assigned to what? Turn here. So process value क्या हो सकता है? Either 0 or 1. You can take anything, okay, whichever the process you are executing, so that will be that process value. So okay, you can take process value 0 or 1, whatever you execute. So process value will be assigned to turn. And next, in the while loop, okay, you are executing this. So turn equal to process. The while loop you are checking this, turn equal to process. Remember, if this condition is true, and this is a and. Okay, look at here, this is a double ampersand here, double ampersand, and interested of other is also true. Let us say for example this is also true. Okay, it's an and operation. And operation में क्या होता है बताओ? Okay, if the both are true, then only condition becomes true. Right? Simple and operation. So if the both are true, the condition becomes true here. Okay. So if this is true and this is true, then the entire condition becomes true. Then the process will stop here. Process will stop here. Remember, while semicolon. The answer देखो यहाँ पे while semicolon है. So while semicolon क्या होता है? If the condition is true, the process will stop there, and if the condition is false, it will enter into what? A critical section. So we have seen the examples in the while, okay, semicolon also, right? So don't worry. So that is the meaning of while semicolon. Okay. So if the condition is true, then it will enter into critical section. Condition is true, process will stop there. Condition is false, it will enter into what? A critical section. And next, it will make use of the shared variable, shared resources here. And once it is completed the critical section, while leaving the critical section, जब CH छोड़ के बाहर जा रहा है, तो क्या करेगा? Interest of process equal to क्या करेगा? False करेगा. So it will make interest of process equal to false. So that is how, okay, the code will execute. Now we need to do the analysis. Now we need to do the analysis and understand how the code is actually working. So whether it is a correct solution or incorrect solution. So we are going to, okay, do the analysis. Okay, मेरे साथ में करो analysis. Okay, मेरे साथ में करो. मैं कैसे चेंज कर रहा हूँ वैल्यूज, मेरे साथ में करो, क्योंकि कोड चलाना आपको आना चाहिए. कोड चलाना आपको आना चाहिए. So understand here. So let us do the analysis. Note down analysis लिखो. Okay, so take it as analysis. So initial values, so copy this also in the analysis, inside the analysis. Okay, so I write here then. Okay, analysis 1. Okay, just take it as analysis 1. We will do the 2 analysis. ये copy करो. Interest of 0 false, interest of 1 false. इसके अंदर copy करो फिर से. Analysis 1 में interest of 0 false, interest of 1 false. And the next I am writing here. So turn, there is no value in the turn. Okay, initially there is no value. Okay, so next P0 के लिए we are going to write this side, and P1 के लिए we are going to write this side. And here is the critical section. Copy all this. ये पूरा copy करो अच्छे से. Copy all this. Okay, in the analysis, okay, interest of 0 is false, 1 is false. Initially that is given to you. ये भी copy करो. Turn में कोई value नहीं है. So there is no value in the turn. Okay, turn को ऊपर लिखना है यहाँ पे. ऊपर लिखना है क्योंकि turn is a shared variable. Okay, very good. So turn is a shared variable. यहाँ पे ऊपर लिखना है. So P0 here and P1 here. Nobody is there in the critical section. Okay. Right. So next, now what I am going to do here, listen here. Okay, if anybody is still copying, pause my video and copy. Right. So next, okay, so next what we are going to do is, first we will check for the mutual exclusion. Now tell me how you check for the mutual exclusion. First, inside the critical section only one process should be allowed. So critical section करने, sorry, mutual exclusion check करने के लिए कोई procedure technique नहीं है, but we'll do some kind of practice. Okay, first let's say first P1 को अभी CS में लाएंगे यहाँ पे. ओके उसके बाद P0 को चेक करेंगे, या तो P0 को पहले लाएंगे बाद में P1 को चेक करेंगे. सो विल डू ओके हिट एंड ट्रायल ऑल पॉसिबिलिटीज. सो फर्स्ट व्हाट आई विल डू इज आई एम गोइंग टू ब्रिंग P0 इनटू क्रिटिकल सेक्शन. ध्यान से सुनो अच्छे से. P0 को क्रिटिकल सेक्शन में लाऊंगा, उसके बाद P1 को चेक करूंगा. ओके फर्स्ट आई विल ब्रिंग P0 इनटू क्रिटिकल सेक्शन, लेटर आई ओके चेक फॉर द P1. सो व्हाट इज गोइंग टू हैपन, लेट अस डू द ओके एनालिसिस. सो मेरे साथ में करो, चेंज द वैल्यूज ओके अलोंग विथ मी. राइट. ओके okay fine. So now first I am taking okay process value as a 0. okay बताओ okay P0 को चलाना चाह रहा हूँ. first I want to bring P0 into critical section. तो process value क्या लेना चाहिए, 0 लेना चाहिए. so okay integer process, so process value 0 लिया, process value 0 लिया. so integer other, other is a local variable. so यहाँ पे लिखो P0 के लिए other, P0 के लिए other. so other equal to 1 minus process, other equal to 1 minus process. so process value क्या है बताओ, 0. so 1 minus 0, 1 minus 0 means what, that is 1. so other value क्या होगा बताओ, 1 होगा. right. so interest of process equal to true. understand here. so interest of process equal to true here. okay understand here. interest of process equal to true. so what is the process value, okay 0. okay process value क्या है बताओ, 0. so interest of 0 becomes what, true. ओके इनिशियली क्या था, ये इंटरेस्ट ऑफ 0 क्या था, फॉल्स था. तो इसको क्या करना है बताओ, ट्रू करना है. सो इंटरेस्ट ऑफ 0 इज द ट्रू. ओके एंड द नेक्स्ट अंडरस्टैंड हियर. सो टर्न इक्वल टू प्रोसेस, मेरे साथ में करो पूरा अच्छे से. ओके इंटरेस्ट ऑफ 0 को ट्रू किया सब लोग. एंड नेक्स्ट टर्न इक्वल टू प्रोसेस. सो प्रोसेस वैल्यू विल बी असाइन टू टर्न. टेल मी व्हाट इज द प्रोसेस वैल्यू, 0. सो 0 विल बी असाइन टू टर्न. सो लुक एट हियर. सो टर्न में क्या होगा, 0 होगा. And the next after that while turn equal to process, now you are checking this condition, you are checking this condition while turn equal to process. now tell me what's the turn value, turn value 0. Okay, turn value 0. What's the process value? 0. So turn equal to process. True or false? True. This condition is true. Listen carefully. Okay, turn equal to process. This condition is true because turn value 0 hai and process value 0 hai. And next, interest and interested of other. Now what is the other? What is the other for the P naught here? P naught के लिए other क्या है बताओ? 1. So other value is 1. So interested of 1 equal to true. Now tell me, interest of 1 equal to true. So interest of 1 is true or false? Okay, look at here, false. So interest of 1 is false. So it means what? So this condition is false. Okay, and this condition is true. This condition is false and this condition is true. The entire condition is false. Entire condition is false. Then what happens? Okay, the process will enter into critical section. देखो ये true है, ये false है. This is true and this is false. The entire condition becomes false. So the entire condition becomes false. So it will enter into what? Critical section. Okay, right? So now, so P naught is coming into critical section. Right? So I am writing here also. जैसे यहाँ पे भी लिख रहा हूँ just for easy understanding. So P naught CS में आया. So अभी करना क्या चाहिए बताओ? P naught is in the critical section. Okay, no need to write here. Okay, just okay. So P naught is in the critical section. Now when P naught in the critical section, now try for what? P1. P1 को check करो. So P1 भी आना चाह रहा है, तो आ पाएगा? नहीं आ पाएगा. So the answer सुनो अच्छे से. Okay. Now I am executing the code for the same. Okay, P1. Okay, same code for the P1. Okay, understand here. So process value क्या लेना है बताओ? 1 लेना है. P1 को चलाना चाह रहा हूँ तो process value 1 लेना है. मेरे साथ साथ में कर रहा हूँ एनालिसिस, जैसा मैं चेंज कर रहा हूँ वैल्यूज ऐसे आप लोग करना चाहिए. So now first interested of process. Okay, so integer process value 1. P1 भी आना चाह रहा है तो क्या होगा? Integer other is a local variable. So write down here, other is a local variable. Other equal to 1 minus 1. So 1 minus 1, that is a 0. Other value will be 0. Next, interest of process equal to true. What is the process value? 1. So interest of 1 equal to true. Okay, look at here. So interest of 1, it was false. So now this condition becomes true here. Next, now turn equal to process. So process value will be assigned to turn. So what's the process value? 1. So 1 will be assigned to turn. So now look at here. So turn value becomes 1. Okay, and the next, so after that, okay, listen here. So after that, what happens here? Next, turn, okay, process value will be assigned to turn. Next, now you are checking the while loop here. While loop check kare. While turn equal to process. Listen here. So while turn equal to process, tell me turn equal to process. What is the turn value? 1. Okay, what is the process value? 1. So this condition is true. This condition is true. Next, and interested of other equal to true. Interest of other equal to true. Now tell me what is other value? P1 के लिए other क्या है? What is other for P1 here? Okay, 0. Okay, P1 के लिए other क्या है? 0. So interested of 0 equal to true. Interest of 0 equal to true. True or false? Okay, look at the interest of 0 is true. So that is true. Okay, look at here. So this condition is also true. Right? So now what happened? So this is true and this is true. The entire condition becomes true. Then the process will stop there. Okay. So look at here. So P1 will stop there and P1 cannot enter into critical section. So इसका मतलब जब तक आपका P naught यहाँ पे critical section में है, जब तक P naught critical section में है, तो P1 क्या होगा? इसी में घूमता रहेगा. So P1 will keep on rotating in the while loop here. Is that clear? So next, okay, this is, so when P naught is in the critical section, so P1 is clearly not allowed. When P naught in the critical section, so P1 is not allowed. So next, what you guys do is, you guys do the analysis again, okay, next analysis, analysis 2, okay, copy all these values. आप लोग क्या करो, P1 को पहले लाओ CS में, उसके बाद P naught को चेक करो. P1 को पहले CS में लाओ, उसके बाद P naught को चेक करो. Write down all the values. Write down all the values clearly. Okay, take it as a analysis 2 and initial value of okay, interest of 0 false and interest of 1 is also false. And next, there is no values here. यहाँ पे कोई values नहीं है. Write down all the values clearly again. Once again, पूरा लिखो. Okay, don't be lazy. Don't be lazy. So पूरा copy, पूरा okay, analysis में जो दिया गया, analysis 2, okay, ये पूरा कॉपी करो. इनिशियली इंटरेस्ट ऑफ 0 फॉल्स, 1 फॉल्स, टर्न में कुछ भी नहीं है, P naught P1 पूरा लिखो अच्छे से. सो पहले क्या करना है बताओ आपको, P naught को पहले CS में लाना है, उसके बाद में P1 को फिर से चेक करना है. सॉरी, पहले P1 को लाना है, सॉरी, P1 को पहले CS में लाना है, उसके बाद में P naught को चेक करना है. सो ट्राई करो. सो डियर स्टूडेंट्स, dear students, I think okay, you have done the solution, right? So in the analysis 2, okay, what you are finding out, what you found, okay, first when you try for the process P1, when you try for process P1, so P1 is coming or not coming? Yes, okay, P1 is coming to critical section, and afterwards when you try for P0, so P0 is also coming or not coming? So P0 is not coming into critical section, okay. So where the P0 will stop? So P0 will stop in the while loop, so it will keep on checking all these conditions and P0 will stop here. So it means it is very clear. So what you understand from this is, when P1 is there in the critical section, so P0 is not allowed, and when P0 is there in the critical section, so P1 is not allowed. So you can try in any possible manner, only one process will come into critical section. So it means mutual exclusion is satisfied. Mutual exclusion is satisfied. So I am going to write here. So the first condition is what? Mutual exclusion. Mutual exclusion is satisfied. Okay, mutual exclusion is satisfied. Now understand the important statement what I am saying here. Now here, in order to check the mutual exclusion, so what you have done? In order to check the mutual exclusion, पहले अपन क्या किए बताओ? We are doing, we have first brought P0 into critical section and later you are checking for P1, and we brought P1 into critical section, later you are checking for P0. Remember, whatever the procedure I am showing here, that is not a standard procedure. Listen to me carefully. Whatever the procedure I am showing here, that is not a standard procedure. Okay. Now remember, there is no any specific technique or approach to solve the problem. It is purely logical. Is that clear? So whatever the solution, whatever the procedure I showed here, that is not a standard procedure. ऐसा नहीं करना चाहिए. कैसा करना चाहिए? कोई procedure technique नहीं है. It is all purely logical. Like for example, you can take preemption here, you can take preemption here, you can take preemption here, you can take preemption here. Okay, you try in all possible cases. If there is only one process coming into critical section, so then you will say mutual exclusion is satisfied. And in case if you find even a single case where the two processes are coming into critical section, so it means mutual exclusion is not satisfied. Is that clear? So that point you should understand. So here you try in any possible manner, just wait, you try in any possible manner, okay, only one process coming into critical section, so that is the reason you say what? Mutual exclusion is satisfied. So the next, now the second condition. Now think and tell me. The code आपके सामने, कल का क्लास में मैं प्रोग्रेस बताया था. Okay, in the previous algorithm we discussed the progress. So second condition, think about the second condition. Progress is satisfied or not satisfied. Okay. Now remember, so in this entire explanation, somebody may have a small doubt. Don't worry about all that. Okay, I'll clarify all that. Okay, I know what kind of doubt you will get. Okay, right. So first, think about only progress first now. Progress is satisfied or not satisfied? So please pause my video and take 1-2 minutes time. Think carefully. Second condition, progress. Pause my video. Okay. Now let us discuss the progress. Now tell me, coming to the progress, satisfied or not satisfied? Progress is satisfied. Okay, simple. So progress is satisfied. So I think most of you got same. So by this simple example only, already we discussed the progress only. Why? Because see, when the P0 is there, okay, P0 can comfortably come into critical section first time. When the critical section is free, listen to me. When the critical section is free, P0 can comfortably come into critical section. There is no problem. When P1 is, okay, critical section is free, okay, completely free, and P1 is coming into critical section, it can comfortably come into critical section. तो मतलब कोई भी आ सकता है. When the critical section is free, P0 can come into critical section. When critical section is free, P1 can come into critical section. So there is no problem of progress. Okay. And in case if anybody is having, okay, doubt, like okay, somebody thinking progress is not satisfied, okay, listen here, those who are thinking progress not satisfied, you may be doing like this. क्या करते हैं first सब लोग? Okay, generally you may do like this. Somebody taking preemption here. Okay, listen here. Somebody is taking preemption here. So when you take preemption here, void leave region, okay, यहाँ पे preemption किया, मतलब interest of process को false नहीं किया और यहाँ पे preemption लिया. और यहाँ पे प्रियम्पशन लेके अगर कोई प्रोसेस को लाना चाहते हैं तो इज पॉसिबल, दैट इज नॉट पॉसिबल. ओके, दैट इज नॉट पॉसिबल. अभी यहाँ पे प्रियम्पशन लेके you are taking preemption here and assuming that critical section is free, so that is wrong. Remember, when you take preemption here, even though you take preemption here, okay, you have to consider the critical section is busy only. Remember, unless and until the process is not executing, the interruption of process equal to false. Unless and until the interruption of process equal to false, okay, you need to consider that process is still inside the critical section only. Is that clear? So, okay, what I am trying to say, when you take preemption here, okay, it means what? Critical section busy only. When the critical section is busy, there is no the thinking of okay, progress. Progress comes. Okay, situation comes into picture only when the critical section is free. Okay, so now even if you take preemption here, okay, you need to consider critical section is busy only. So when the CS is busy, so there is nothing to talk about progress. Okay. And next, now somebody may think about the deadlock. Okay, कुछ लोगों को deadlock मिलता है. Okay, remember there is no deadlock here. There is no deadlock here. अगर मिल रहा है किसी को, some students maybe 100 में एक को मिलता है generally. Okay, because students will come to us asking the doubts. Okay, they may find the deadlock. I will discuss. Okay, I will discuss. मैं पूरा discuss करता हूँ. Okay, tension मत लो बिल्कुल भी. पूरा discuss करता हूँ. Right? Okay. So there is no deadlock here. So progress is satisfied. So after this, if still anybody is having still doubt, okay, don't worry, okay, there is a long way to go. Okay, I will explain that also. If anybody is having small doubt also, okay, I will explain. Okay, don't worry. So as of now, just okay, no doubt, progress is satisfied. And the next, the third condition is bounded waiting. Okay, so what is the meaning of bounded waiting? I gave you the definition. Okay, already proper definition I have explained, and I told you I have given the notes also. And code is in front of you, but remember bounded waiting कैसे चेक करना वो तो मैं नहीं बताया था अभी तक. ओके, पहले चांस मैं आपको दे रहा हूँ. The first chance I am giving it to you to check for the bounded waiting. Okay, after that I will explain. Okay, don't worry. So first, okay, I am giving the chance to you to check for the bounded waiting because देखते कितने लोगों को सही में समझ में आया. Let's find out how many of you really understood the definition of the bounded waiting. So, okay, just revise the notes. Okay, just go to the bounded waiting definition. एक बार पढ़ो. Just read the definition of the bounded waiting and just apply in this. Okay, code is in front of you. All the values are there and check bounded waiting is satisfied or not satisfied. Okay, you can pause my video again. Remember, you should know. Okay, if you don't do the analysis, okay, even if it is wrong, गलत भी होने दो, सही भी होने दो, तुमको ट्राई करना है. गलत भी हुआ तो क्या होगा? गलत भी हुआ तो आप अच्छे से याद रखेंगे कि कैसे गलत हुआ, क्यों गलत हुआ, आप कैसे सोचे थे और मैं कैसे बता रहा हूं. Okay, so what was your thinking and what was my analysis? You can make the proper comparison and improve your analysis skills. So don't sit idle. Okay, remember you are not watching movie. You are not watching movie. You are listening the class. It is just like a regular class. Okay, so imagine I am just in front of you. Okay, right. So please pause the video and check for bounded waiting. Okay, right. So now understand here. Next, if you check for the bounded waiting, so let's see what is the right answer. देखते हैं कितने लोगों को सही आया. So bounded waiting is satisfied. The right answer is what? Bounded waiting is satisfied. Okay, so the right answer is bounded waiting is satisfied. Okay, so check karo. Okay, how many of you got the right answer? So if it is a live class, okay, maybe offline class, I would have seen you, but let's see. Bounded waiting is satisfied. So how it is bounded waiting satisfied? The answers I will explain all the details. So listen to me carefully. Okay, so first I am bringing the P0 into critical section. Listen carefully. So I am bringing P0 into critical section. Void enter region integer process. So process value is 0. Okay, I am bringing P0 into critical section. And next integer other. So other. So I am writing here other. Other equal to 1 minus 0, that is 1. And interest of process equal to true. Process value is 0. Interest of process equal to true. So look at here. So this value becomes true here. That value becomes true. And next, so after that, okay, turn equal to process. So process value will be assigned to turn. So process value will be assigned to 1. What is the process value? 0. and the next while turn equal to process, listen carefully, follow carefully, while turn equal to process, turn value कितना है बताओ, turn value 0, so that is a 0, process value कितना 0, so this is true, turn equal to process true, and next and interest of other, now tell me what is other for p naught, so p naught के लिए other क्या है 1, so interest of 1 equal to true, true or false, false, so look at here, so this condition is false. So this condition is false, this condition is true, the entire condition is what? False. If it is false, the P naught will come into critical section. So I am writing here P naught coming into critical section. So P naught is in the critical section here. Now remember, so P naught is in the critical section now. Okay, अभी तक मैं क्या किया? ध्यान से सुनो, अभी तक मैं क्या किया? सिर्फ P naught को critical section के अंदर लाके रख दिया. What I have done till now is I just brought the P naught into critical section and kept there. Now I did not check for the bounded weighting, okay, till now. Now I am checking for the bounded weighting. Now I am checking for the bounded weighting. Listen here. So now P naught अभी CS के अंदर है. So now I am bringing the P1 into critical section. So I am bringing P1 into critical section. Listen here. What happens? Why the enter region integer process value 1 लेना है. P1 चला रहा है तो 1 लेना. Integer other. So other is a local variable. So I am writing here. Remember other is a local variable इसलिए separate लिख रहा है. So it is a global variable, shared variable है, इसलिए टर्न को क्या लिखे, ऊपर लिखे. वो तो यहाँ समझ में आ रहा है ना सबको, right? And next, okay, so next other equal to 1 minus 1, so that is a 0. Interest of process equal to true. So interest of process, okay, this value becomes true here. Okay, and turn equal to process. So process value will be assigned to turn. Now tell me what is the process value here? 1. So process value 1, so that becomes, okay, turn value becomes 1. Now you are checking this, turn equal to process, turn equal to process. Listen here, turn equal to process, okay, turn value 1, process value 1. So this is 1, this is 1, this is true. And interested of other, listen carefully, P1 के लिए other क्या है, P1 के लिए other क्या है, 0. So interest of 0 equal to true. Okay, now look at here. So interest of 0 equal to true, true or false, true. So this is true and this is true. The entire condition is true. Now the P1 will stop here. P1 will stop here. Okay. Now understand carefully. Understand carefully. So मैं क्या किया था? P naught को पहले simply CS में लाके रख दिया. उसके बाद P1 को चेक किया तो P1 यहाँ पे रुक गया. तो P1 क्या करता रहेगा? P1 will keep on reading these variables and checking this condition. So turn, okay, process, okay, both are true, okay, this is true, okay, again check this, interest of, okay, other equal to true. If it is true, again, okay, check the while loop, okay. So P1 while semicolon मतलब क्या था? While semicolon मतलब if the condition is true, okay, it is keep on rotating the while loop. इसका मतलब turn equal to process, true, okay, interest of other equal to true, again entire condition is true, इसमें घूमते रहना, चेक करो दोनों true है, फिर से okay इसमें घूमना, फिर से चेक करो okay true है, okay again keep on rotating in the while loop for the condition to become false. So इसी में घूमता रहेगा, जब भी इसका scheduling मिलेगा, whenever the P1 is scheduled, so it is keep on checking only while loop while reading these variables. That is the point. Next, now what is the meaning of bounded weighting? I told you important point. What I said, okay, you need to imagine that all the process these two are executing in the round robin scheduling with the time quantum. इसका मतलब जब इसका time quantum है ये चलेगा, जब इसका time quantum है वो चलेगा. That's the first point. Next point. And next, now coming to the bounded weighting. Bounded weighting का बात अभी मैं कर रहा हूँ. What's the meaning of bounded weighting is, okay, when P naught in the critical section here, that is fine. Now P1 weighting should be what? Bounded, limited. It means what? It means bounded weighting का definition में क्या था? What is the definition of the bounded weighting? The first statement you have written in the bounded weighting, no process should have to wait forever to enter into critical section. So some processes keep on waiting, okay, to enter into critical section. ऐसा नहीं होना चाहिए. कैसा होना चाहिए? Second point लिखे थे. Second point, there should be a bound on getting chance to enter into critical section. There should be a bound on getting chance to enter into critical section. Bound मतलब क्या है? Okay, limitation. आपको पक्का बोलना चाहिए. ये एक process, okay, बाहर निकलते ही पक्का इसी को chance मिलेगा. Okay, after two processes coming out of the critical section, definitely this will get a chance. after 10 processes coming out of the critical section, definitely this will get a chance. So the chance, the waiting of the process to enter into critical section should be bounded. It means what? After how many processes this will get a chance, that number should be bounded, that number should be definite, that number should be limited. Okay, so definite value होना चाहिए. इसका मतलब आपको पक्का बोलना चाहिए P1 क्या बोलना चाहिए, P1 के लिए क्या बोलना चाहिए. अभी P1 यहां पे वेट कर रहे हैं, लिसन केयरफुली, P1 यहां पे वेट कर रहे हैं, अभी P0 यहां पे. सो आपको पक्का बोलना चाहिए एक प्रोसेस क्रिटिकल सेक्शन से बाहर निकलते ही इसी को चांस मिलेगा, या 2 प्रोसेस बाहर निकलते ही पक्का इसी को चांस मिलेगा. ओके, सो P1 का जो वेटिंग है वो बाउंडेड होना चाहिए. P1 का वेटिंग शुड बी बाउंडेड. P1 का जो वेटिंग है बाउंडेड होना चाहिए. नाउ आई एम आस्किंग द क्वेश्चन टू यू. So look at here, P0 is here and P1 is here. P1 is keep on checking this file condition. Now I am asking the question. So waiting of the P1 is bounded or unbounded? Bounded or unbounded? Bounded. Why? Because when the P0 is leaving the critical section, when the P0 is completed the critical section and it is leaving the critical section, then what happens? Okay, it will execute interest of process equal to false. So P0 will simply say interest of process equal to false. Okay, whenever the P0 says the interest of process equal to false, and immediately this condition becomes false. This condition becomes false for the P1 and P1 will enter into what? Critical section. So next पक्का P1 आएगा CS में. Is that clear? Okay, the answer सुनो अच्छे से. P0 अभी बाहर जाते ही इंटरेस्ट ऑफ प्रोसेस को फॉल्स करेगा. P0 बाहर जाते ही इंटरेस्ट ऑफ प्रोसेस को फॉल्स करेगा. सो ये फॉल्स करते ही क्या होगा? P1 के लिए ये कंडीशन क्या होगा? फॉल्स होगा. P1 के लिए कंडीशन फॉल्स होगा. ओनली P1 विल एंटर इनटू क्रिटिकल सेक्शन. रिमेंबर, ओके, इट मींस अपन पक्का बोल सकते. क्या बोल सकते? P1 ओके, P0 बाहर जाते ही पक्का इसी को चांस मिलेगा. मतलब इसका जो वेटिंग है ओके बाउंडेड है. एक प्रोसेस बाहर जाते ही इसी को चांस मिलेगा. वन प्रोसेस इज लीविंग द क्रिटिकल सेक्शन, डेफिनेटली दिस गेट ए चांस. सो P1 का जो वेटिंग है बाउंडेड है, तो इसलिए बाउंडेड वेटिंग सेटिस्फाइड है. इज दैट क्लियर? So now somebody may think sir bounded वेटिंग obviously ये satisfy होगा, क्यों नहीं होगा satisfied? ओके, अगर ऐसा कुछ हो सकता है क्या? रिमेंबर, मैं ऐसा कोड लिख सकता हूं. देखो यहां पे P0 अभी बाहर गया. ओके, यहां पे क्या था? P0 यहां पे था. आई एम कमिंग फ्रॉम द फर्स्ट. ध्यान से सुनो, अभी बाउंडेड वेटिंग कब सेटिस्फाई नहीं होता था? ओके, अगर कोड ऐसा था P0 यहां पे था, P1 यहां पे चेक कर रहे हैं, तो P0 ये बाहर गया, अब फिर से P0 ही फिर से अंदर आया. P0 बाहर गया, फिर से अगर ट्राई करे तो P0 ही फिर से अंदर आया. P1 यहीं पे वेट कर रहा है. फिर से P0 गया, फिर से P0 अंदर आया. P1 को जब भी ट्राई कर रहा है वाइल कंडीशन ट्रू मिल रहा है. P0 बाहर गया, फिर से P0 अंदर आया. P0 फिर से बाहर गया, फिर से अंदर आया. P0 जब भी ट्राई कर रहा है इसको ट्रू मिल रहा है. अगर ऐसा होता तो क्या होता? बाउंडेड वेटिंग नॉट सेटिस्फाइड. सो वो सिचुएशन यहां पे नहीं होता. इज दैट क्लियर? सर ऐसा हो सकता है क्या? आप जो ऐसा बोले ऐसा हो सकता है क्या? यस, ऐसा कोड मैं लिख सकता हूं. आगे अपन देखेंगे पूरा. ओके, अगर ऐसा हो रहा है तो बाउंडेड वेटिंग नॉट सेटिस्फाइड. इज द पॉइंट क्लियर? राइट है. सो डोंट वरी, अभी भी थोड़ा डाउट छोटा हो सकता है. कोई भी डाउट है इसमें भी, अभी भी डाउट होता है. ओके, थोड़ा डाउट होता है. सो किस लोगों को ये होता है सर ये कंडीशन क्यों दिया गया? टर्न इक्वल टू फॉल्स, टर्न इक्वल टू ट्रू क्यों दिया गया? छोटा डाउट हो सकता है. You may have small doubts. Don't worry, all the doubts will be rectified. So just please be patient and follow me carefully. I clearly know what doubt you will get and where you will get and why you will get. Okay, I will try to make everything possible. Okay, everything clarify. Okay, right. So understand here. So these three conditions are satisfied. Okay, copy this. Please copy this. Mutual exclusion satisfied, progress satisfied, bounded waiting satisfied. Copy this. Okay, right. So if you are not okay, not copied, then please make a pause of the video. Right, note down the statement. Note down. We have proved. Proved that all the three conditions are satisfied. All the three conditions are satisfied. Hence, solution is considered to be correct solution. Solution is considered to be correct solution. Fine. Okay. Next, let's take up the question. Next, note down the question. So, if you solve this question, okay, then it means now you are following the code in the logical manner. Okay. Note down the question. Question likho. Assume that. Please note down the question. Assume that both the processes P0 and P1 are entering into critical section. Both the process P0 and P1 are trying to enter into critical section at the same time. Repeat कर रहा हूँ. Assume that both the process P0 and P1 are trying to enter into critical section at the same time. Then which process will enter into critical section first? Which process will enter into critical section first? Okay. So that is the question. Okay. I will give the options here. Okay. ओके क्वेश्चन तो समझ में आया ना, राइट. क्वेश्चन में तो कुछ डाउट होना ही नहीं चाहिए. ओके सिंपल क्वेश्चन है. ओके दोनों प्रोसेस आना चाह रहा है, दोनों प्रोसेस क्रिटिकल सेक्शन में आना चाहिए. जब दोनों आना जा रहा है तो ऑब्वियसली कितने प्रोसेस आएगा? एक ही प्रोसेस आएगा, बिकॉज म्यूचुअल एक्सक्लूजन इज सैटिस्फाइड, ओनली वन प्रोसेस विल कम इनटू सीएस, राइट. सो ये बोल रहा है कि जब दोनों ट्राई कर रहा है कौन सा प्रोसेस पहले सीएस के अंदर जाएगा, दैट इज द क्वेश्चन, राइट. सो नोट डाउन द ऑप्शंस. द प्रोसेस व्हिच एग्जीक्यूट्स statement, okay, just listen here. Okay, give the numbering there first. This is the first statement, second statement, third statement, fourth statement, and this is the fifth statement. Give the numbering. Notes में लिखो 1 2 3 4 5. Okay. Now the process which executes a statement 2 first. Okay. The process which executes statement 2 first. Statement 2 मतलब क्या है? ये वाला. Exactly. Other equal to 1 minus process. ये वाला अगर पहले चल रहा है तो वो process पहले जाएगा. Next, option B. The process which executes statement 3 first. Option B में the process which executes statement 3 first. Option C, the process which executes statement 4 first. The process which executes statement 4 first. Option, okay, statement 4 मतलब क्या है? ये वाला turn equal to process. Statement 3 मतलब क्या है? Interest of process equal to true. And statement 2 मतलब ये वाला. Okay. And option D, we cannot say. मतलब अपन बोल नहीं सकते. We cannot say particularly. पक्का बोल नहीं सकते. It may happen in anything. Okay. That is the meaning. We cannot say. So I am repeating question. Okay, right. Assume that both are trying to enter into critical section. So दोनों process आना चाह रहे हैं तो कौन सा process पहले CS के अंदर जाएगा? Which process will come into CS first? So the process which executes statement 2 first. Okay. And the process which executes statement 3 first. Option B. And process which executes statement 4 first. That's option C. And we cannot say. Option D. Okay. So think carefully and try to solve. Question is logical. Okay, don't make the blind guessing. Guessing will not work. Guessing will not work in the GATE exam. I'll wait around 5 to 10 seconds in the live. So please pause my video and solve the question. Okay, right. So I am just revealing the answer. So let's see what is the right answer for this. So right answer is okay. What is the answer you are getting? Right answer is C. C is the right answer. Okay, listen here. The process which executes statement 4 first, only that process will enter into critical section first. जो process statement 4 को पहले चलाएगा वो पहले CS के अंदर जाएगा. Okay, so that is the okay answer. Right. Okay, so statement 4, this one, turn equal to process. So I will show you the clear analysis. Okay, how that is correct. Remember, just to do the analysis. Okay, इसको prove करने के लिए statement 4 जो process पहले चलाएगा वही पहले CS के अंदर जाएगा. So इसको prove करना चाहिए. Prove करने के लिए what I will do is statement 3 को ध्यान से सुनो अच्छे से. Statement 3 को पहले P0 से चलाऊंगा, बाद में P1 से चलाऊंगा. I will execute statement 3 first by P0 and later P1. And I'll execute statement 4 okay by P1 first and later P0. Okay, पहले इसको P0 से पहले चलाऊंगा, बाद में P1 से. इसको पहले P1 से चलाऊंगा, बाद में P0 से चलाऊंगा. अगर ऐसा चलाऊंगा, okay, if I execute like this, then what happens? दोनों प्रोसेस यहां तक खत्म किया होता. Okay, look at here. दोनों प्रोसेस यहां तक खत्म किया होता और दोनों प्रोसेस आके while लूप को चेक करेगा. दोनों प्रोसेस आके while लूप को चेक करेगा और जिसके लिए फॉल्स है ओके वो अंदर जाएगा. Exactly. So अभी somebody may have a doubt, सर आप ऐसा क्यों कर रहे हैं? ओके, लुक एट हियर, मैं क्या कर रहा हूं, पहले इसको पहले P0 से करूंगा, पहले बाद में P1 से, इसको पहले P1 से चलाऊंगा, बाद में P0 से. ओके, किसी को डाउट है ऐसा क्यों कर रहा हूं, ऐसा क्यों कर रहे हो? ऐसा नहीं करे तो कैसे करोगे? राइट, सो ऐसा नहीं करे तो कैसे करोगे? लिसन हियर. सो अगर पहले इसको मैं P1 से चलाऊंगा, अगर समझो इसको भी मैं पहले P0 से ही करूंगा तो डिफरेंस कैसे पता चलता? सिंपल सी बात, राइट. सो इसको भी पहले P0 से कर रहा हूं, इसको भी पहले P0 से कर रहा हूं, तो डिफरेंस आपको कैसे मालूम होगा? सो आई विल एग्जीक्यूट बाय दिस बाय P0 फर्स्ट एंड बाद ओके आफ्टरवर्ड्स P1 एंड दिस बाय P1 फर्स्ट एंड आफ्टरवर्ड्स P0 and then what happens, both are complete up to here and both the process will come and check the while loop, execute the while loop and whichever okay for the process it becomes false and that will enter into critical section. So hope okay what I am going to do I explained okay in prior so that okay you can understand the analysis properly. मैं पहले ही बता चुका हूं मैं क्या करने वाला हूं, exactly, क्योंकि आपको अच्छे से समझ में आने के लिए, right. Okay, now the answers सुनो. So let's do the analysis. Okay, so I am writing all this. Okay, बताओ initial values क्या था? ये भी false था. Okay, ये भी false था and there is no value in the turn. Okay, listen carefully. The answer सुनो अच्छे से, पूरा अच्छे से ऑब्जर्व करो, अच्छे से ऑब्जर्व करो क्या कर रहा हूं. फर्स्ट मैं P0 को चला रहा हूं, राइट. सो बोथ आर कमिंग, बोथ आर ट्राइंग टू एंटर फर्स्ट P0. ओके, सो वाइड एंटर रीजन इंटीजर प्रोसेस वैल्यू 0 इंटीजर अदर. सो यहां पे लिखा है अदर and other equal to 1 minus 0, so that is other value is 1, so I written that, and interest of process equal to true. Now look at here, so this value becomes true. Now tell me, so who executed this? Okay, first that is the P0, मैं P0 से पहले चलाया. Okay, now so I executed this by P0. Let us say after P0 and next now P1 is coming. Okay, because both are executing in the time quantum with the round robin scheduling. Okay, जब इसका time quantum है वो चलेगा, जब उसका time quantum है वो चलेगा, सिंपल सी बात. So next now P1 is coming, so process value क्या लेना? 1 लेना. Okay, integer other, so other is a local variable, यहाँ पे लिखा है other equal to 1 minus process, so 1 minus okay process value 1 है तो 1 minus 1 0, यहाँ पे लिखा है already, and interest of process equal to true. So process value क्या है? What's the process value now? 1. So okay, this becomes okay true here. And now tell me, अभी इसको किसको, ये statement को कौन चलाया अभी? Okay, P1 चलाया. And next turn equal to process. So I am executing this statement. So who is executing this statement? P1. So P1 executed this statement. So turn equal to process value will go into turn. What is the process value? 1. So look at here, so turn value becomes 1. Next now look at here, so P1 is completed up to here. Okay, 4 statement completed. Now P0 is also coming back. Okay, P0 यहाँ पे समझो preempt हुआ था, P0 is coming back. So now P0 will execute which statement? Turn equal to process. Okay, both are executing, time quantum से अपना अपना time quantum से चल रहा है बस. Okay, so when P naught is coming back, it is executing this statement. So look at here. So P naught executing this. बताओ, when P naught executing this statement, turn equal to process. So P naught का process value will be assigned to turn. So P naught executing this statement, P naught का process value क्या होता है? 0. So 0 will be assigned to turn. देखो यहाँ पे turn value अच्छे से observe करो, turn value क्या हो गया? 0. Turn value becomes 0. Now, so what happened now? अभी क्या हुआ बताओ? दोनों process यहाँ तक खत्म किया. Both the processes executed up to this statement. Now both the process will come and execute the fifth statement. So for whichever the process, this becomes false and that will enter into critical section. So is the point clear? Right. So now execute. Now let us say P naught is executing this statement. P naught is executing this statement. Listen carefully. So when P naught is executing this statement, turn equal to process. P naught executing this statement, P naught process value will be 0. Now what's the turn value? Turn value 0. Turn value 0. Turn is a shared variable. Both the process are having same variable. Okay, sharing the same variable. So turn value 0. So look at here. So turn equal to process. This condition is true. Okay, P naught के लिए process value P naught 0 है तो P naught. So this condition interest of process other equal to true. So this is anyway true because both are true only. Both are true only. So this condition is true and this condition is true. Okay, both are true. The condition is true. Entire condition is true. The process will stop here. So P naught यहाँ पे रुक जाएगा. P naught will stop here. देखो क्या हुआ अभी? What you understood? Okay, for the P naught, both the conditions are true here. So P naught will stop there. So remember, P naught is executed the statement 3 first. P naught executed the statement 3 first, but P naught is not going to enter into critical section. P naught executed the statement 3 first, but P naught is not entering the critical section. It means there is no role of statement 3. Statement 3 का कोई मतलब नहीं है. And next, now P1 is trying to execute. Now P1 आना चाह रहा है, तो बताओ P1 आना चाह रहा है, तो क्या होगा? ध्यान से सुनो अच्छे से. P1 आना चाह रहा है, P1 चला रहा है, P1 एग्जीक्यूट कर रहा है while loop को, तो प्रोसेस वैल्यू क्या लेना? 1. And tell me what's the turn value? Turn value, final value of the turn you have to take. What's the turn value? 0. So look at here. So turn value 0. Okay. So 0 equal to 1. True or false? False. So look at here. So this condition becomes false here. Now P1 will enter into what? Critical section. So look at here. Now P1 will come into critical section. Is the point clear? Right. So now look at it. So this condition is false and this condition is true. Now P1 will enter into critical section. So is the point clear for everyone? Right. So it means what you understood. Okay. Statement 1, 2, 3 का कोई मतलब नहीं है. जो process statement 4 को पहले चलाएगा, statement 4 को जो process पहले चलाएगा, वही process पहले CS के अंदर जाएगा. Is the point clear for everyone? Okay. So next, in case if anybody is still having doubt, small doubt अभी भी थोड़ा हो सकता है अगर है तो. Okay, I'll show you one more analysis. Listen carefully. Okay, so I'm reviewing all this. Okay. So this is false and this is false. There is no value in the turn. So I am coming from the first complete. Okay, पहले से बता रहा हूँ. This complete the new analysis. Okay, little different analysis. Okay, the answer सुनो. अभी थोड़ा भी doubt है. Okay, if you have a small doubt also. Okay, all the doubts will be clarified. So please wait. So now understand here. Okay, I am doing the analysis. I am coming from the first again. Listen carefully. Now I am executing P naught. So process value will be 0. I am executing P naught integer other. So other, okay, यहाँ पे लिखा है other equal to 1 minus 0, that is 1. So other value is 1. Interest of process equal to true. So process value you have to take as 0. So interest of 0 equal to true. So this value becomes true. Listen carefully. Listen carefully. Now P naught executed up to third statement. Okay, third statement is completed. Now look at here. So who executed this statement first? P naught. Now let us say after executing the third statement, now P naught is getting preempted. P naught is getting preempted. After executing third statement, मैं already बताया था. क्या बताया था? Important points में लिखे थे कल का previous session में. Okay, preemption may occur at any point of time after completion of the current instruction, but preemption is just a temporary stop. The process will come back and continue the remaining execution. I hope okay, you remember that point. So I am assuming P naught is getting preempted here. Listen carefully. So P naught is getting preempted here, P naught execute up to here, and P naught is getting preempted. Now I am checking for the P1, checking for the P1. If I want to check for the P1, so process value you have to take as what? 1. Process value you have to check 1. Okay, integer other equal to 1 minus 1, so that is 0. Interested of process equal to true. Now or the okay, that is now this is executed by P1, so interest of process equal to true. Look at here, so this condition this value becomes true. And next, now turn equal to process. The answer sunna hai say process value will be assigned to turn. Now tell me who is executing this statement? P1. Okay, P1 executing this statement. Turn equal to process. Process value will be assigned to turn. What is the process value? P1 चला रहा है तो process value क्या लेना? 1. Okay, already बताया था यहाँ पे P1 चला रहा है तो process value 1. So okay, turn value क्या होगा? 1 होगा. Now P1 executed this statement. Now P1 is executing while loop. Listen carefully. P1 executing while loop. Okay, while turn equal to process. Now tell me what's the turn value? 1. And what is the process value? 1. So this is true. And interested of other. Okay, देखो ये दोनों true है already. So this is anyway what? True. Look at here. So this condition is true and this condition is true. The entire condition is true. The process will stop here. Okay, look at here. P1 will stop here. P1 यहाँ पे रुक गया. P1 will stop there. So what you understood now? What you understood? Okay, what you understood now? Okay, P1 executed statement 4 first. स्टेटमेंट 4 को P1 ने पहले चलाया मगर P1 अभी CS के अंदर नहीं जा रहा है. ओके, P1 is not going to critical section now because this is also true and this is also true, the entire condition true. P1 will stop there. P1 executed this statement first, but now P1 is not going into critical section. Now what is my question to you? What is my question to you is will you change your answer or stick to the same answer? आपका आंसर को चेंज करोगे या ओके स्टिक टू द सेम आंसर? मैं बताया पूरा वैल्यूज आपके सामने एनालिसिस करके. P नॉट यहाँ पे प्रीएम्पशन किया था. P1 अभी पहले इसको चलाया था. P1 पहले इसको चलाया, P1 आके इसको चेक कर रहा है तो P1 ओके लिए ट्रू हो गया, P1 यहाँ पे रुक गया. So P1 executed the statement 4 first, but P1 is not going into critical section. So now tell me, will you change your answer or stick to the same answer? आइडिया आपको आना चाहिए. मैं कैसे ये बताऊंगा. ओके, right. So answer is okay, right answer is C only. Okay, right. Okay, now understand here why it is like this. Okay, look at here. So P1 is okay trying. Okay, A be true. Okay, condition is true. That is fine. But remember what is the P naught situation? P naught is preempted. अभी बताया. Preemption is just a temporary stop. Process will come back and continue remaining execution. अब बताओ P1 what the P1 is doing? P1 is checking this condition. P1 turn equal to process. Turn equal to process. This is true and this is true. Okay, execute here only. Turn equal to process. This is true. This is true. Execute here only. Okay, again turn को read करो, process को check करो. Okay, true है तो इसमें घूमो. Right, remember once P naught is preempted, okay, and P naught is coming back, it will definitely resume back. Okay, we will again schedule when P naught is again coming back and it will continue the remaining execution. So when P naught is coming back and P naught will make okay this statement here, P naught will execute this statement. When the P naught is executing turn equal to process, when the P naught executing turn equal to process, P naught process value will be assigned to turn. What the P naught process value is? 0. Now this turn value becomes what? 0. अगर ऐसे ही ये turn value 0 हो जाएगा, ऐसे ही ये turn value 0 होगा, so P1 के लिए ये कंडीशन P1 टर्न वैल्यू क्या रीड करेगा? 0 रीड करेगा. सो P1 के लिए ये कंडीशन क्या होगा? फॉल्स होगा. देखो P1 के लिए कंडीशन फॉल्स होगा एंड P1 ओनली विल एंटर इनटू क्रिटिकल सेक्शन. इज द पॉइंट क्लियर? सो ऐसे ही P नॉट आके इसको चेंज करेगा, टर्न को ओके 0 करेगा. ओके, देन द P1 विल रीड द टर्न वैल्यू 0 एंड P1 विल ओनली एंटर इनटू क्रिटिकल सेक्शन. अगर P नॉट आके भी ट्राई करता है, अगर P नॉट आके ट्राई भी करता है तो क्या होगा? P नॉट यहां पे रुक जाएगा. P नॉट आके भी अगर इसको चेक भी करता है फिफ्थ स्टेटमेंट को, P नॉट यहां पे रुक जाएगा. ओके, ओनली P1 के लिए ये कंडीशन फॉल्स होगा. ओनली P1 विल एंटर इनटू ओके क्रिटिकल सेक्शन फर्स्ट. सो इट मींस व्हाट? इसका मतलब क्या है? आप प्रीएम्पशन, नो प्रीएम्पशन, डू व्हाटएवर यू वांट, ऑप्शन सी इज ऑलवेज करेक्ट. So do whatever you want, okay, preemption, no preemption, do whatever you want, options is always correct. So this is how, okay, you have to do the analysis. Hope all the points are clear for everyone. Okay, now somebody may have a doubt, okay, there is a deadlock in this, there is no deadlock. Okay, even if you are having still, okay, somebody अभी भी किसी को छोटा डाउट अभी भी होता है, okay, प्रोग्रेस के लिए, okay, मुझे पता है, okay, so किसी को डाउट है तो वेट करो थोड़ा, okay, it's a like long process. Synchronization I will teach around 10 hours, more than 10-12 hours. Okay, sometimes in the regular class, normal offline class, I teach around 16 hours, 16-17 hours. So please wait. Okay, there's so many things to be discussed. So please wait. So this is how, okay, you discuss the Peterson algorithm with all the points. So hope it is clear for everyone. Okay, so this question is important. All the questions going forward will be similar kind of question. The questions will be logical. So you can answer the questions only if you understand the logical meaning of each and every statement. Okay, so that's what you need to do in every question. Okay, thank you. So next, okay, we'll move on to the next type of solution. Okay, remember we have completed, okay, software type of solution. We have seen log variables, strict toleration and Peterson algorithm. So with that we completed, okay, software type of solutions. Next, we will move on to the next one, that is the hardware type of solution. So you can make the heading hardware type of solutions. Keep the heading hardware type of solution. Okay, in the hardware type of solution, okay, we will study TSL instruction set. So in the TSL instruction set, we are going to use something called TSL register flag. TSL register flag, what is this means? Copy karo. Copies the current value of flag, copies the current value of flag into register and stores the value of 1 into flag in a single atomic cycle. Without any preemption. Without any preemption. Okay, so understand carefully. Okay, what is the meaning of this? Let's try to understand. I will explain all that in detail. First, copy karo अच्छे से. So let's see, note down the code also. TSL RIMA flag, compare the resistance value with the 0. Third instruction, J and Z, jump if it is non-zero to step 1. Critical section. Okay, store M of flag. Okay, so that is 0. Store the value of 0 into flag. So copy this. Please copy the code properly. Pause my video. And next, you are having the flag value. Flag value takes two things, either 0 or 1. Okay, if the flag value is 0, that means CS is free, and flag value 1, it means CS is busy. Copy this. Right. So if still copying, just pause my video and copy. Right. So let's discuss this. TSL instruction set. What is the meaning of TSL? TSL मतलब क्या बताया? Test and set lock. Test and set lock. Listen here. So TSL means what? Test and set lock. Okay. See, set करना मतलब क्या होता है? Test and set करना, set lock. Set करना मतलब हमेशा 1 करना. Simple सी बात है. Okay. Okay. In the digital terminology, set करना मतलब 1 करना, reset करना मतलब 0 करना. Okay. So that you should remember. Okay. Now in the TSL, we will use something called TSL register flag. So in this, what happens? What this TSL register flag will do is copies the current value of flag into register. Okay, the answer is no. Copies the current value of flag into register. Current value जो of the flag जो भी रहेगा, it copies that into register. See, flag value can be what? So two things. Flag value can be either 0 or 1. So if the flag value 0, that means CS is free. Flag value 0 means free. Flag value 1 means that is a busy. That is the meaning of representation of the flag. So copies the current value of flag into register and stores the value of 1 into flag. Stores the value of 1 into flag in a single atomic cycle. Okay, this is important. Atomic cycle without any preemption. Okay, without any preemption, atomically it will copy that. Atomically it will copy that. Okay. Now it means what? It means it copies the current value of flag into register and stores the value of 1 into flag in a single atomic cycle without any preemption. Is the point clear? So it means okay, loading and storing both are happening in a single instruction. Loading and storing both are happening in a single instruction. Is it clear for everyone? Right. Okay. So understand here. So that is about TSL register flag. Now, okay, understand here. So this is a code given to you in the entry section. We are having critical section here. Now, first of all, the next thing, listen carefully. So in the code, he has not given anything about number of process. In the code, he has not given anything about what? Number of process. So it means, okay, remember, okay, you can understand, you can execute the code for any number of process. Okay, listen carefully. It can be used by any number of process like P1, P2, P3, P4, dash, 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 Pn. Remember, but Peterson algorithm works only for 2 process. Strict toleration works only for 2 process. Okay, okay, listen carefully whatever I said. So next, okay, so TSL, it can be used by any number of process. It means what? You are having P1, P2, P3, P4, any number of process. All the process are trying to access the common critical section, and we are trying to provide synchronization to the processes to access the common critical section. हम लोग करना क्या चाह रहे हैं? We are trying to provide synchronization to the processes to access the common critical section. Is that clear? And next, okay, this is the code given to you. So just go through the code here. First instruction, TSL RI M of flag. Now tell me, same thing here, RI. Okay, TSL RI M of flag. So what is this I? I told you already. So I means what? Respective process register. Respective प्रोसेस रजिस्टर. सो इसका मतलब क्या होता है? हर प्रोसेस का अपना अपना रजिस्टर होगा. ओके, एवरी प्रोसेस विल हैव इट्स ओन रजिस्टर. सो यू टेक फॉर एग्जांपल P1, you have to take R1, P2, R2, so P3, R3, so like that. So TSL RI M of flag. What happens in this instruction? TSL RI M of flag. What happens in this instruction? Whatever I have written here, the same thing will happen here. So it means what? It copies the current value of flag into register and stores the value of 1 into flag in a single atomic cycle without any preemption. So that is, okay, now listen here. If you want to execute this instruction without any preemption, if you want to execute this instruction without any preemption, you need to disable all the interrupts in the hardware level. You need to disable all the interrupts in the hardware level. Okay, now understand here, if you want to disable all the interrupts, okay, you need to disable all the interrupts in the, okay, hardware level. So that is the reason, the solution is of type what? Hardware type of solution. Solution is of type hardware type of solution. Is it clear for everyone? Right. So first instruction, repeat कर रहा हूँ, क्या होगा यहाँ पे? Copies the current value of flag into register and stores the value of 1 into flag. And second instruction, you are comparing the register value with 0. You are comparing, okay, CMP matlab comparing, register value is 0. So why you are comparing with 0? To identify whether CS is free or busy. And the next, the third instruction, jump pivot is non-zero to step 1. If it is non-zero, okay, then you jump to what? Step number 1. So non-zero means what? It is 1. So if it is 1 means what? CS is busy. If it is busy, then okay, you simply jump to step number 1. तो मतलब अगर busy है तो non-zero तो क्या करेगा? 1 2 3 करेगा. non-zero है फिर से okay, इसको चेक करेगा 1 2 3. अगर 0 है तो then you will enter into what? Critical section. And then okay, we'll enter into critical section and make use of the shared resources and shared variables here. See, critical section मतलब क्या है? Shared variables है, okay, shared resources है. So this is also what? A set of instructions only. Set of instructions only. Critical section may also have 1 lakh instructions or 10 lakh instructions, but all the shared instruction. That is the meaning of critical section. And next, while leaving critical section, जब CS छोड़ के बाहर जा रहा है, so what you are doing here? You are storing the value of 0 into flag. When the process leaving critical section, you are storing the value of 0 into flag. So, okay, that's what happens in the 5th instruction. So, when you are storing the value of 0 into flag, it means what? You are releasing the critical section. You are leaving the critical section or releasing the critical section. Is that clear? Right. And remember, important point, unless and until you are not executing the statement number 5. Unless and until you are not executing the statement number 5, okay, remember, you need to understand, you need to consider that process is still inside the critical section. Okay, what I am trying to say, क्या बताना चाह रहा हूँ यहाँ पे, इसका मतलब somebody may be doing like this. So, okay, you are taking preemption here. Okay, you are taking preemption here and thinking that okay, critical section is free. That is wrong. Even if you take preemption here, you need to consider CS is busy. Unless and until the flag value becomes 0, you cannot consider the CS is free. Okay, so that is the okay point to be noted. Okay, next. Now, same thing, what you have to do here now? बताओ क्या करना चाहिए अभी? We need to do the analysis. Understand what is satisfied, what is not satisfied. Where is the correct solution or incorrect solution? Okay, so the answers सुनो अच्छे से. Okay, so I'll explain the analysis. Okay. So, in the analysis, I am assuming initial value of flag is 0 and nobody is there in the critical section. Okay, initial value of a flag is 0 and nobody is there in the critical section. Just listen, okay, carefully. Okay. Now, code can be used by what? Any number of process. So, first we will check for the mutual exclusion. So, one by one we will check. So, first, okay. So, let us do the analysis. Okay, just listen carefully. So, first we will check for the mutual exclusion. Okay, first we will check for the mutual exclusion. Okay, so listen here. So, first I am going to bring P1 into critical section. So, let us do some procedure. So, let us take a separate register for the P1 here. Remember, every process will have its own register. हर process का अपना अपना register होगा, right? You know that already. So, P1 executing the first instruction. Tell me what happens in the first instruction? TSL RI M of flag. What happens in the first instruction? Copies the current value of flag into register. Copies the current value of flag into register and stores the value of 1 into flag. Copies the current value of flag into register and stores the value of 1 into flag. Now, tell me what happens? Copies the current value of flag into register and stores the value of 1 into flag. Okay, understand here. And next, now P1 executing the second instruction. What is the second instruction? Okay, understand here. Compare the register value with the 0. Compare the register value with the 0. Okay, when you compare the register value with 0, now tell me 0 or non-zero here? 0. Okay, right, no problem. Next, now P1 executing third instruction. What the third instruction says? J and Z, jump if it is non-zero to step 1. Now tell me, will it jump here? No, it will not jump because it is a 0. It is 0, it will not jump to step number 1. And next, now P1 executing the fourth instruction. So it means what? Entering into critical section. Okay, ये fourth instruction नहीं बोल सकते इसको. Okay, third instruction हो गया तो इसका मतलब वो CS के अंदर आ चुका है. Is that clear? Right. So even if it is not given also, no problem. Third instruction execute हो चुका है. So it means now it is in the critical section only. That's it. Okay. So now, okay, P1 is in the critical section here. Okay. Now let your P1 be in the critical section. Let your P1 be in the critical section. Now try for P2. Let's say, okay, remember code can be used by any number of process. P1, P2, P3, P4 आप कितने भी ले सकते हो. So next, let's execute the P2. Now P2 is trying to enter. So let's see what will happen now. When P2 is entering, now P2 executing the first instruction here. Okay, what is the first instruction? TSL RI M of flag. TSL RI M of flag. Okay, P2 executing the first instruction. So the answer is no. P2 executing first instruction. TSL RI M of flag. Okay, what happens here? यहाँ पे क्या होगा? Same thing. यहाँ पे जो लिखा है वही होगा, right? Copies the current value of flag into register and stores the value of 1 into flag in a single atomic cycle without any preemption. So copies the current value of flag into register. So take the sub register for P2. हर process का अपना अपना register होगा. Copies the current value of flag into register and stores the value of 1 into flag. Okay, so ये 1 है already, फिर भी 1 ही करेगा. And next, now P2 executing second instruction. Tell me what happens? Okay, compare the register value with 0. So when you compare this register value with 0, okay, 0 or non-zero, okay, non-zero. Next, now P2 executing third instruction. So when you execute third instruction, jump pivot is non-zero to step 1. Tell me, will it jump here? Yes. So it will jump to step number 1. Will jump to step number 1. So it means what? Now P2 will keep on executing this. 1, 2, 3. 1, 2, 3, 1, 2, 3 इसी में घूमता रहेगा. अगर जब तक ये नॉन जीरो है तो इसी में घूमता रहेगा. Is it clear? So what you understood now? So when P1 is in the critical section, so P2 cannot enter into critical section. So remember, you can try in any possible manner. You can try in any possible manner. You can try in any possible manner. Only one process will enter into critical section. So it means mutual exclusion is satisfied. Okay. So understand here. So the first condition I am writing here. So first condition, mutual exclusion is satisfied. Okay. So you can try in any possible manner. No need to follow only this procedure. आप preemption, no preemption आप कैसे भी try करो, कुछ भी करो, एक ही process के अंदर जाएगा तो mutual exclusion is satisfied. Now I am having small question to you. We studied the first solution we studied is what? पहला solution क्या पढ़े थे अपन? Lock variables. So in the lock variables, okay, lock variables में we had a similar kind of code only, just like that. In the lock variable also we had a similar kind of code. In the lock variables, mutual exclusion is satisfied or not satisfied? In the lock variables, mutual exclusion satisfied, not satisfied? Not satisfied. Now on the TSL, mutual exclusion is satisfied. So what is the difference? What's the difference? Why it is not satisfied there and why it is satisfied here? Okay, right. So idea तुमको आना चाहिए. So in the lock variables, loading and storing happening in the different instruction. In the lock variables, loading and storing happening in the different instructions. Okay, इसलिए मैं क्या किया था वहाँ पे? What I have done there? Okay, before storing the value, okay, I have taken the preemption in the lock variables. So that is the reason I dissatisfied mutual exclusion. But remember, in the TSL, you cannot take the preemption like that because loading and storing both are happening in a single instruction without any preemption. So that is the reason mutual exclusion is satisfied here. Okay, point clear? Right. Next. Now the second condition is what? Progress. Now, so think of it. Okay, code is in front of you. Okay, now check for the progress here. Okay, you can pause my video. Code is in front of you. Check for the progress. Pause my video. Right. So now tell me, progress satisfied or not satisfied? Progress is satisfied. Progress is satisfied. Okay. So if anybody is having doubt, don't worry. Okay, clear हो जाएगा. Now in case if anybody taking preemption here, अगर कोई यहाँ पे preemption कर रहा है, you are taking preemption here and considering critical section free, that is wrong. ओके अगर यहाँ पे कोई प्रीएम्पशन ले रहा है ओके समझ जाए कि क्रिटिकल सेक्शन फ्री है, अभी दूसरा प्रोसेस नहीं आएगा. सो दैट इज रॉन्ग एनालिसिस. ओके, इफ यू टेक प्रीएम्पशन हियर इट मींस लॉजिकली क्रिटिकल सेक्शन ऑलरेडी बिजी. And next, somebody taking preemption here. So even if you take preemption here, already you stored flag value as 1. जब आप इंस्ट्रक्शन इसको चला दिया तो flag value क्या बना दिया आप? Flag value already made as what? 1. So when you already made the flag value 1, it means okay, you are already reserving the critical section. You are locking the critical section and you need to consider critical section as a busy only. Why? Because even if you take preemption temporary stop. When the process coming back, it will directly enter into critical section. So already it is reserved. Okay, when it is executed this, it is reserved the critical section. So it is reserved and it will, okay, when the process coming back, it will directly enter into critical section. So it means you need to consider CS is busy only. Is the point clear? Right? So it means just like आप ताला लगा दिया, so ताला लगा दिया तो मतलब बंद कर दिया तो मतलब ताला लगा दिया, ताला लगा दिया मतलब busy है. Is that clear? Right? Okay, so something like that. Okay, fine. Next, now third one is important. अगर आप सही सोचा है, so then that is really good. So third condition is what? Bounded waiting. Okay, so third condition is a bounded waiting. So please pause my video and check for the bounded waiting. Okay, अगर ये वाला सही सोचा है तुम, then that is really good, really very very good. Flag value 0, nobody in the critical section. बाउंडेड वेटिंग चेक करो, कोड आपके सामने है. बाउंडेड वेटिंग क्या होता है मैं ऑलरेडी बता चुका हूं. ओके, पीटरसन में बता चुका हूं, क्लियरली बताया. सो कोड आपके सामने है. सो लेट दिस साइड पॉज माय वीडियो. चेक फॉर बाउंडेड वेटिंग. Right. So now understand here. Let's do the analysis. Okay, for the bounded waiting. So देखते कितने लोग सही सोचा है. Okay. So bounded waiting. बताओ. Bounded waiting is satisfied or not satisfied? So right answer is not satisfied. Okay. Maintain smile on the face. थोड़ा smile करो. Okay. Movie नहीं देख रहे हैं. Okay. Feel like you are in the class only. So bounded waiting is not satisfied. Okay, so don't worry. क्योंकि कुछ लोगों का सही हुआ है, कुछ लोगों का गलत हुआ है, मुझे पता है, right? So I'll explain all that. आपको क्या डाउट आता है पूरा पता है मेरे को, so थोड़ा सुनो अच्छे से, right? Okay, I'll come to all the points, right, one by one. So first, okay, bounded waiting not satisfied. Now listen here. So initially flag value 0. Let's say nobody there in the critical section. Then the answer is no. P1 executing first instruction. Example, जैसे P1 is coming into critical section. Okay, so when P1 coming into critical section, so I'm taking separate register for the process P1. Now P1 executing first instruction, TSL RI M of flag. What happens here? Copies the current value of flag into register and stores the value of 1 into flag. Now P1 executing second instruction. What is the second instruction? Compare the register value with 0. So when you compare the register value with the 0, is it 0 or non-zero here? When you compare the register value 0 or non-zero, okay, 0, no problem. So now P1, okay, executing third instruction. What the third instruction says? Jump if it is non-zero to step 1. Tell me, will it jump here? No, it will not jump. Now P1 executing the fourth instruction. So entering into critical section. So P1 is coming into critical section. Okay. So now remember, अभी तक मैं क्या किया? P1 को CS में लाके रख दिया. बस इतना ही किया. P1 को CS में लाके रख दिया. इतना ही किया. ओके, अभी तक बाउंडेड वेटिंग को चेक नहीं किया. ओके, सो नाउ आई एम चेकिंग द बाउंडेड वेटिंग. सो नाउ P1 द क्रिटिकल सेक्शन. नाउ P2 is trying to enter. Let's see what will happen. Now P2 executing the first instruction. What is the first instruction? TSL RIM of flag. So I have to take the separate register for the process P2. Okay, I am taking separate register for process P2. Okay, first instruction क्या बोलता है? Same thing. Okay, TSL RIM of flag. So copies the current value of flag into register and stores the value of 1 into flag. Now P2 executing second instruction. What is the second instruction? Compare the register value with the 0. When you compare register value with 0 or non-zero here? Non-zero. Now P2 executing the third instruction. Now what is the third instruction? Jump if it is non-zero to step 1. Okay, will it jump here? Okay, yes. Okay, it will jump to step number 1. Because it is non-zero, so it will jump to step number 1. So बताओ P2 क्या करेगा? लिसन केयरफुली. P2 क्या करेगा? इसी में घूमता रहेगा. ओके, फर्स्ट इंस्ट्रक्शन कंपेयर करेगा. नॉन जीरो है तो जंप करेगा. 1 2 3, नॉन जीरो है जंप करो. 1 2 3, इसी में घूमता रहेगा. इज द पॉइंट क्लियर? राइट. सो ध्यान से सुनो, अभी ध्यान से सुनो. P1 अभी CS में है, अब P2 ट्राई कर रहा है तो इसी में घूमेगा. सो ओके, 1 2 3 में घूमता रहेगा. नेक्स्ट, आफ्टर P2, P3 is also trying to enter. Then what happens? This will also rotate. Same thing in the 1 2 3 instructions because critical section is busy and flag value 1. And after P3, next P4 is also trying, then also it will keep on rotating only in the 1, 2, 3 instructions. After that, P5 trying, that will also rotate in the same instructions. P6 is also trying, it will also rotate in the same instructions. Listen to me carefully. Listen to me carefully. Now, when the P1 in the critical section, okay, उसके बाद P1 CS के अंदर गया था पहले, उसके बाद कौन ट्राई किया, उसके बाद P1 के बाद कौन ट्राई किया, P2, P2 के बाद P3, P4, P5, P6. Remember, all these processes are repeatedly checking for this 1, 2, 3 instructions and waiting for the flag value to become 0. जब भी इसका टाइम क्वांटम चल रहा है, ओके, ये सारे प्रोसेस क्या कर रहे हैं, इसमें घूम रहा है, ओके, इसमें घूम रहा है, 1 2 3 1 2 3 1 2 3 घूम रहा है. रिमेंबर, व्हेन P1 is leaving the critical section, when P1 is leaving the critical section, it will make the flag value to what? It will make the flag value to 0. Okay, look at here. So P1 is leaving the critical section and is making the flag value to 0. So when, remember, when it's making the flag value to 0, then okay, you don't have any guarantee. You don't have any guarantee that next process P2 only will enter into critical section. P1 आपका बाहर गया, P1 ने फ्लैग वैल्यू 0 करके बाहर गया, उसके बाद कोई गारंटी नहीं है, पक्का P2 ही जाएगा बोल के कोई गारंटी नहीं है. सो कोई भी प्रोसेस इसमें से जो प्रोसेस फ्लैग वैल्यू 0 रीड करेगा वही प्रोसेस CS के अंदर जाएगा. इसमें से जो प्रोसेस फ्लैग वैल्यू 0 रीड करेगा वही प्रोसेस CS के अंदर जाएगा. वो कोई भी प्रोसेस हो सकता है वो P6 हो सकता है वो P5 हो सकता है वो P10 हो. इज इट क्लियर? नाउ देयर मे बी अ चांस दैट समझो P6 गया, ओके, उसके बाद ओके P5 गया, उसके बाद P10 गया, उसके बाद P4 गया, उसके बाद ओके P11 गया. सो जब भी P2 ट्राई कर रहा है इसको हमेशा बिजी मिल रहा है, जब भी P2 ट्राई कर रहा है फ्लैग वैल्यू 1 मिल रहा है, इसको बिजी मिल रहा है. ओके, इसका मतलब क्या है? सो देयर मे बी अ चांस फॉर द प्रोसेस P2 टू गो इनटू व्हाट? इंडेफिनेट वेटिंग. इंडेफिनेट वेटिंग, बिकॉज P1 जब आपको CS का छोड़ के बाहर गया तो पक्का नेक्स्ट पक्का P2 ही जाएगा बोल के कोई गारंटी नहीं है. कोई भी प्रोसेस जा सकता है. इट कैन बी एनी प्रोसेस कैन गो इनटू क्रिटिकल सेक्शन. इज दैट क्लियर? सो इट मींस व्हाट? ओके, द क्रिटिकल सेक्शन ऑलवेज बिजी बाय सम अदर प्रोसेस एंड जब भी इसको ट्राई कर रहा है इसको हमेशा CS बिजी मिल रहा है. सो लेट्स सी व्हाट इज द डेफिनेशन ऑफ द बाउंडेड वेटिंग. गो टू द नोट्स, गो टू बाउंडेड वेटिंग डेफिनेशन में जाओ. नोट्स में बाउंडेड वेटिंग का डेफिनेशन में जाओ. थर्ड पॉइंट पढ़ो, उसमें थर्ड पॉइंट सम प्रोसेस, बाउंडेड वेटिंग का थर्ड पॉइंट क्या लिखे? जल्दी कहां पे नहीं मिल रहा है किसी को नोट्स में? स्टूपिड फेलोस. बाउंडेड वेटिंग का डेफिनेशन थर्ड पॉइंट. सम प्रोसेसेस आर indefinitely waiting to enter into critical section. Some processes are indefinitely waiting to enter into critical section because critical section is always busy by some other processes. This situation, आगे क्या लिखे? This situation should not arise. Okay, मगर यहाँ पे क्या हो रहा है? वो situation arise हो रहा है. Is that clear? So some process indefinitely waiting to enter into critical section. It's on. Okay, some process indefinitely waiting to enter into critical section because critical section is always busy by some other process. Okay, आगे क्या लिखे? This situation should not arise, but that situation is okay arising here. So that is the reason bounded waiting is not satisfied. Is the point clear? Right. Next. Now somebody will still have a doubt. What is the doubt they have? Okay, guess करो doubt क्या हो सकता है? Doubt ये होता है, sir अभी तक आपने क्या बोला? Okay, you have to generally practically you have to imagine what a round robin algorithm. Okay, if I execute all these process by using round robin, then what happens? Okay, that is their doubt. Okay, listen here. So don't worry about all your doubts. I will clarify all your doubts. Please listen to me patiently. Now practically I told you generally practically round robin will use okay most of the systems. अगर ये सारे process को listen to my question carefully. In the round robin, do you have a starvation or no starvation? Round robin में starvation होगा नहीं होगा? Very clear. Round robin में starvation नहीं होगा, right? Next question is, if all these processes are executing by using strictly round robin algorithm only, if all these processes are executing strictly by round robin algorithm only, then bounded waiting is satisfied or not satisfied? That is my question. If all these processes are executed by using round robin algorithm, then bounded waiting satisfied or not satisfied? Pause my video. I will wait 5 to 10 seconds. Then I will explain. आपको आइडिया आना चाहिए। डर गए क्या? Right. Now understand here. So let's see what is the right answer. Okay, remember, okay, even though you are executing all these processes by using round robin algorithm, bounded waiting is not satisfied. Right answer is bounded waiting is not satisfied. Sir, how bounded waiting not satisfied? Process will definitely get a chance, right? उसको तो chance तो मिलेगा ही मिलेगा, क्योंकि starvation नहीं है round robin में. Okay, right. Okay, what is the right answer? Right answer is, let's try to understand. Right answer is, okay, listen here, bounded waiting is not satisfied. Why not satisfied? Round robin will give a chance for the process to execute. Round robin will definitely schedule the process. Round robin will definitely schedule the process to execute. But remember, round robin will not do anything for the process to enter into critical section, and to enter into critical section, flag value should be what? 0. राउंड रॉबिन ने प्रोसेस को शेड्यूल किया, चांस तो देता है पक्का वो, राइट? सो जब वो चांस दिया, समझो उसको फ्लैग वैल्यू हमेशा 1 मिल रहा है, 1 मिले तो क्या होगा? इसी में घूमता रहेगा, इसी में घूमता रहेगा। राउंड रॉबिन तो चांस तो दिया चलने के लिए, मगर इसी में घूम रहा है, फ्लैग वैल्यू 1 है, इसी में घूम रहा है, उसका टाइम क्वांटम खत्म हो गया तो वापस आ गया रेडी क्यू में, राइट? सो राउंड रॉबिन पक्का क्या करता है? चांस तो देता है, मौका तो देता है, चांस तो देता है, किस लिए? शेड्यूल करने के लिए, एग्जीक्यूट करने के लिए, चलने के लिए मौका देता है, मगर क्रिटिकल सेक्शन के अंदर जाने के लिए राउंड रॉबिन कुछ नहीं करता है। ओके, क्रिटिकल सेक्शन के अंदर जाने के लिए फ्लैग वैल्यू क्या होना चाहिए? 0 होना चाहिए। अभी भी किसी को डाउट है, सर ये कैसे, समझ में नहीं आ रहा? ओके, इधर सुनो। ओके, राउंड रॉबिन का रेडी क्यू बना रहा हूं। ओके, ध्यान से सुनना है, अच्छे से ध्यान से सुने तो ही समझ में आएगा, पूरा ध्यान इधर ही रखना। ओके, सो इनिशियली फ्लैग वैल्यू क्या था? 0। ओके, फ्लैग वैल्यू 0। ओके, ध्यान से सुनो अच्छे से। नोबडी इन द क्रिटिकल सेक्शन। राउंड रॉबिन का रेडी क्यू बना रहा हूं। राउंड रॉबिन का रेडी क्यू याद है? राउंड रॉबिन का रेडी क्यू याद है? ओके, राइट, याद होगा ऑब्वियसली। ओके, राइट। सो फर्स्ट नाउ P1 इज कमिंग इनटू क्रिटिकल सेक्शन। सो P1 अपने को रेडी स्टेट में आया था, सो पहले P1 को रेडी क्यू में लिखेंगे, राइट? ध्यान से सुनो अच्छे से। P1 आया तो P1 आया, ओके, शेड्यूल भी हो गया, रेडी स्टेट में सेलेक्ट किया अपन, शेड्यूल हो गया। नाउ P1 ओके, मेकिंग द फ्लैग वैल्यू 1 एंड एंटर्ड इनटू क्रिटिकल सेक्शन, राइट? ध्यान से सुनो, P1 पहले शेड्यूल हुआ, फ्लैग वैल्यू 1 करके वो CS के अंदर आया। नाउ अभी P1 अभी एग्जीक्यूट कर रहा है, P1 ओके, क्रिटिकल सेक्शन के अंदर कोड चला रहा है, ओके, शेड रिसोर्स, शेड वेरिएबल को चला रहा है। ओके, क्रिटिकल सेक्शन, ओके, 1 लाख इंस्ट्रक्शन हो सकता है, 10 लाख इंस्ट्रक्शन हो सकता है, कुछ भी हो सकता है। सो P1 यहाँ पे चल रहा है, P1 यहाँ पे चल रहा है, समझो नया प्रोसेस आया, ओके, P2 आया, P3 आया, नया प्रोसेस आया तो पहले अपन उसको रेडी क्यू में डालते, ओके, फ्लो चार्ट याद है राउंड रॉबिन का, राइट? सो नया प्रोसेस आया तो पहले उसको रेडी क्यू में डालोगे, राइट? P2 P3 आया, रेडी क्यू में डाल दिया। रिमेंबर अभी क्या हुआ? P1 अभी भी CS के अंदर है, P1 का टाइम क्वांटम एक्सपायर हो गया, P1 का टाइम क्वांटम एक्सपायर हो गया, मगर अभी भी क्रिटिकल सेक्शन पूरा कंप्लीट नहीं हुआ है, तो क्या होगा? P1 का टाइम क्वांटम एक्सपायर हो गया तो P1 वापस रेडी क्यू में गया, P1 का टाइम क्वांटम एक्सपायर हो गया तो वापस रेडी क्यू में गया। राउंड रॉबिन का रेडी क्यू बना रहा हूं। नेक्स्ट, उसके बाद P2 शेड्यूल हुआ, P2 शेड्यूल किया, देखो अभी क्या हो रहा है? P2 शेड्यूल किया, P2 को चांस तो दे रहा है, राउंड रॉबिन P2 को मौका तो दे रहा है, हाँ, P2 को मौका दिया तो क्या होगा? सो P2 शेड्यूल हुआ तो देखो फ्लैग वैल्यू क्या है बताओ? 1 है, फ्लैग वैल्यू 1 है, तो P2 क्या करेगा? P2 will execute this 1 2 3 instructions, 1 2 3 instructions in this here, and P2 even though scheduled flag value 1, and P2 will keep on executing this 1 2 3 instructions. Remember when the P2 is okay executing on the CPU, naya process, new process arrived, that is P4 and P5 arrived, so you write them in the ready queue first, round robin flow chart. So P4 P5 you write in the ready queue first, and next now P2 time quantum also expired, P2 time quantum also expired, then again the P2 will also go back to what? Ready queue. Next in the line is what? P3. Now P3 again scheduled onto the CPU. Now P3 again scheduled onto the CPU. Now what is the flag value now? 1. So when the P3 is okay scheduled, flag value 1. So P3 will execute only this 1 2 3 1 2 3 1 2 3 instructions. Now when the P3 is executing on the CPU, the new process arrived, P5, P6. I am writing them in the ready queue. Now P3 time quantum also expired. So P3 will again go back to what? Ready queue. So P3 again go back to ready queue. And next in the line is what? Now P1 is there. Listen carefully. Now P1 is there. Now again P1 scheduled. So P1 was already executing critical section. Now it is completed the critical section, code in the critical section, and P1 is leaving the critical section. So it is making flag value to 0. So it is making the flag value to 0 and P1 is leaving the critical section. तो P1 बाहर गया, तो बाहर गया P1 का पूरा एग्जीक्यूशन खत्म हो चुका है, तो उसको वापस रेडी क्यू में लिखना नहीं लिखना, नहीं लिखना. ओके राइट. नेक्स्ट नाउ उसके बाद नेक्स्ट लाइन में कौन है? देखो नेक्स्ट लाइन में कौन है? Who is there in the line? The next okay, next is P4. Now remember, next when you are scheduling P4 here, P4 is getting the flag value as 0 and it will make flag value 1 and it will immediately enter into critical section. Look at here. So it means what? Okay, actually after P1, which process came into ready queue? P2. But P2 is not going to critical section. Who is going to critical section? P4. Is that clear? So in the same manner after P4, okay, समझो P5 आया, P6 आया, P7 आया, P10 आया, okay, जब भी P2 ट्राई कर रहा है, इसको हमेशा CS busy मिल रहा है, तो क्या होगा? P2 may go into what? Indefinite waiting. Is it clear for everyone? Right? See, remember, all the things are logical. Entire synchronization is logical. You cannot understand from outside sources. Okay, maybe from textbook also you cannot understand. जो भी समझना है, okay, क्लास में ही समझना है. So please watch the videos carefully. Right. So okay, bounded waiting is not satisfied. So I am writing clearly. So bounded waiting not satisfied. Okay. So इसको कैसे notes बनाते? So think of it. Okay, you now note down properly. Okay, fine. Okay. So next, okay, note down some points. Okay, what is okay, all that you have written. So first condition, mutual exclusion satisfied. कॉपी किए थे ना पूरा, यहाँ पे लिखे थे. Progress satisfied, mutually satisfied, मगर bounded waiting not satisfied. पूरा कॉपी किए थे अच्छे से, right. So next, in the continuation, keep it as a note. Keep it as note. So this is important note. Note down this. Keep it as note. Note में first point लिखो. If some process is in the critical section, then all the other processes which are trying to enter into critical section, will be repeatedly checking for 1 2 3 instructions. यहाँ पे लिख रहा हूँ 1 2 3 like this, 1 2 3 instructions. समझते हुए लिखो, simple. Right? Repeated checking for 1 2 3 instructions. Okay. So simple point, if some process in the critical section, then all the other processes which are trying to enter into critical section will be repeatedly checking for 1 2 3 instructions. Now second point, note down. These processes are busy in checking these instructions. And waiting to enter into critical section. Busy in checking those instructions and waiting to enter into critical section. Full stop. Next. Okay, इसका मतलब second point क्या लिखे? These processes are busy in checking those instructions and waiting to enter into critical section. So third point. This is called as busy waiting. This is called as a busy waiting. This is called as a busy waiting. Okay. Note down. Next point. Busy waiting is also called as a spin lock. यहाँ पे लिख रहा हूँ. busy waiting is also called as a spin lock. Busy waiting is also called as a spin lock. Okay. Okay, it's a technical term. Technical term you have to remember. Busy waiting को क्या बोलते हैं? Spin lock बोलते हैं. Next, fifth point. With busy waiting, they are wasting the CPU cycles. With the busy waiting, they are wasting the CPU cycles. CPU cycles. Cycles मतलब क्या होता है? Time. Okay, braces में लिखो time. CPU cycles मतलब CPU time. Okay, with the busy waiting, they are wasting the CPU cycles. Next point. To avoid the problem of busy waiting, the concept of semaphore is used. To avoid the problem of busy waiting, the concept of semaphore, यहाँ पे लिख रहा हूँ, semaphore पता है ना, semaphore is used. Okay, so now you are understanding, okay, why we are going for the semaphore operation. Semaphore पे क्यों जा रहा है? Okay, right. So in the other these kind of solutions, you are having problem of what? Okay, busy waiting problem. So to avoid this busy waiting problem, we'll go for what? Okay, semaphore. Okay, so how you are going to implement semaphore and how you are going to avoid this problem of busy waiting. Okay, how you are going to avoid the problem of this busy waiting, so that you are going to understand going forward. Okay, so that is about TSL instruction set and busy waiting. Okay, so now understand here next point. Okay, let's make the table with all the properties and all. Okay, just for easy understanding, note down the solution and we'll see all the properties. Mutual exclusion, make the notes, progress and bounded waiting. Okay, solution, okay, mutual exclusion, progress, bounded waiting. So what the first solution we studied? Lock variables. Okay, पूरा एक table में रहेगा. So all that will be in the single table. So let's copy this. First is lock variables. So second, strict alteration or say Decker's algorithm. Okay, so next we studied Peterson's algorithm, TSL instruction set, okay. Copy this table. Lock variables, strict alteration or Decker's algorithm, Peterson algorithm, TSL instruction set. Pause my video and make the table. Okay, and now tell me, just fill the table. TSL instruction set, TSL में mutual exclusion satisfied, अभी पढ़े, mutually satisfied, yes. Progress, yes. Bounded waiting, no. And next, Peterson algorithm, tell me, mutual exclusion satisfied, Peterson में, yes. Progress, yes. Bounded waiting, yes. And strict alteration में progress, mutual exclusion satisfied, yes. Progress, okay, no. Bounded waiting, yes. Check नहीं किए थे, check करो. Lock variables, mutual exclusion satisfied, no. Progress, yes. Bounded waiting, no. Okay, so check कर सकते हो, you can check, okay, after going after this video, okay, you can do that. Okay, so that one, okay, you need to understand. Okay, okay, so that is the, okay, all the algorithms table. right. So next, before we move on to the next one, semaphore, we are having something called small topic called priority inversion problem. Okay, copy this. Priority inversion problem. Copy this. Okay. So what is the meaning of priority inversion problem? Just copy this. In the ready queue, you are having only PL, low priority process, and we are having CPU here, we are having a critical section here. Okay, ready queue. Okay, PL means what? Low priority process. Copy karo. Low priority process. Okay, CPU here and critical section. Copied, right? So just listen here. Okay, what is the meaning of this heading? Okay, understand here. Priority inversion problem. Priority inversion, it means what? There are inversions in the priority. Simple, right? There are inversions in the priority. Inversion in the priority, it means what? You are having some low priority process and high priority process. So, as inversions in the priority. Okay. Now, remember, you are having only one process, PL, okay, in the ready queue now. So, there is no problem. So, directly you are scheduling the PL onto the CPU. Okay. Step number 1, we schedule PL onto CPU. ओके, लो प्रायोरिटी प्रोसेस एक ही प्रोसेस है तो उसको अपन शेड्यूल किया. ओके, यू कैन इमेजिन टीएसएल का एल्गोरिथम इमेजिन करो. टीएसएल अभी पढ़े ना, राइट. सो लेट्स से ऑल द प्रोसेसेस आर हैविंग कॉमन क्रिटिकल सेक्शन एंड पीएल को शेड्यूल किया तो पीएल इज कंफर्टेबली एंटर्ड इनटू क्रिटिकल सेक्शन. सो पीएल अभी सीएस के अंदर आया बाय मेकिंग द फ्लैग वैल्यू 1. ओके, टीएसएल का एग्जांपल इमेजिन करो, टीएसएल को इमेजिन करो, टेस्ट एंड सेट लॉग. ओके, so we scheduled PL onto the CPU and all are having common critical section and it is made the flag value. Okay, बताओ flag value initially 0 था, so it is making flag value 1 and it is comfortably entered into critical section. So it is executing code in the critical section. CPU इसके पास है और CS के अंदर चले गया, CS का शेयर डिस्क को एक्सेस कर रहा है और एग्जीक्यूट कर रहा है. Okay, instructions को एग्जीक्यूट कर रहा है. Now when the PL is executing the critical section, it is in the middle. Now suddenly high priority process is arrived into ready state. High priority process. Now tell me, so when the high priority process arrived into ready state, obviously you need to give preference to what? High priority process. So okay, we have preempted the low priority process and scheduled the high priority process. Okay, scheduled high priority process onto CPU. Look at here. So we have preempted the low priority process and scheduled high priority process onto the CPU. Now remember what happens here. Okay, even though you schedule high priority process onto the CPU, it cannot enter into critical section because critical section is already locked by low priority process. Okay, इसका मतलब क्या है? Already flag value क्या है बताओ? Already flag value 1 है. ये flag value 1 कौन किया था? PL ने किया था. PL ने critical section, PL is not completed the total critical section and PL is not executed the instruction number 5 according to TSL. Okay, it is not made the flag value 0. It is not executed the instruction number 5. The flag value is still 1. Who made this flag value 1? PL is made the flag value 1. So now it was accessing code in the critical section. Suddenly you preempted and you schedule high priority process onto the CPU here. And even though you schedule high priority process onto the CPU, it cannot enter into critical section. Okay, now high priority process is not able to enter into critical section and the low priority process is not able to complete the critical section. High priority is not able to enter into critical section and low priority is not able to complete the critical section. अब बताओ low priority क्यों complete नहीं कर रहे हैं? Low priority critical section पूरा करना है, critical section क्या कोड चलाना है, पूरा रिसोर्स को यूज करना है, critical section complete करना है, तो क्या चाहिए? CPU चाहिए. CPU अभी किसके पास है? हाई प्रायोरिटी प्रोसेस के पास है. तो इसका मतलब हाई लो वाला कंप्लीट नहीं कर पा रहा और हाई वाला अंदर नहीं आ पा रहा. High priority process is not able to enter into critical section and low priority is not able to complete the critical section. So this situation is called as a priority inversion problem, and this is called as a live lock. This is called as a live lock. Okay, copy this. In the live lock, low priority process is now in the ready state and high priority process is now in the running state. So this problem is called as what? Live lock. So that's called as a live lock. So in the live lock, low priority process is now in the ready state and high priority process in the running state. So copy all this 1, 2, 3 steps. Copy all this 1, 2, 3 steps and that box also. Okay. So now understand here. If you are not copied, pause my video. Right. So this problem is called as what? Live lock. So now I want a solution to the problem here. Solution to this problem. क्या करे तो ये problem हट जाएगा? क्या करे तो ये problem हट जाएगा? What is the problem here? क्या problem है बताओ? Problem क्या है? Okay. Problem is okay, low priority process is not able to complete the critical section. High priority process is not able to enter into critical section. So that is a live lock. So ये प्रॉब्लम क्यों हुआ? जब लो प्रायोरिटी प्रोसेस क्रिटिकल सेक्शन के अंदर है तो हाई वाला है तो अपन सडनली प्रीएम्प्ट किया और हाई वाला को शेड्यूल किया, तो क्या हो गया? ये बीच में है, ये पूरा कंप्लीट नहीं किया, पूरा सीएस को रिलीज नहीं किया और इसलिए हाई वाला अंदर नहीं आ पा रहा. सो नाउ व्हाट यू हैव टू डू टू अवॉइड दिस प्रॉब्लम? क्या करे तो ये प्रॉब्लम हट जाएगा? व्हाट इज द सॉल्यूशन? आपको आइडिया आना चाहिए. सॉल्यूशन इज नो डाउन प्रायोरिटी इनहेरिटेंस. Priority inheritance. So what is the meaning of priority inheritance? Look at here. So low priority process having, let's say lowest number is the lowest priority. Let's say low priority process having priority 2 and higher priority process having priority 20. So PL is having priority 2 here and PH is having priority 20 here. Now remember, when the low priority process is in the critical section, when the low priority process in the critical section, when the high priority process arrives into ready queue, ready state, then what you will do is you apply, operating system will apply the priority inheritance protocol. It means we are going to inherit the priority from high priority process to low priority process. I am going to inherit the priority from high priority to low priority. So I am going to change this to what? 20 here. I am going to change this to 20 here. So I am going to inherit the priority from high priority process to low priority process, high priority process to low priority. So I will make this to 20 here. So then what happens? If I do like this, what happens? Priority of both the processes will match. Priority of both the process will match. When the priority of both the process will match, what you follow? Arrival time. Arrival time. Now tell me, on PL and PH, who came first? PL came first. So it means what? PL will only continue the execution and PL will only comfortably continue the critical section and PL will comfortably release the critical section and PL will make the flag value to 0 and later PL पूरा complete होने के बाद, so later high priority process can come into critical section. So the simple solution is one by one they will complete. So अपन ये चाहते हैं कि PL को पूरा उसी को continue करवाओ और PL को पूरा continue करके पूरा complete करके और critical section को release करके flag value 0 करो. So उसके बाद क्या होगा? हाई प्रायोरिटी प्रोसेस कंफर्टेबली क्रिटिकल सेक्शन के अंदर आ सकता है. ओके, सीपीयू के पास आ सकता है. ओके, राइट. सो दैट इज द सॉल्यूशन हियर. ओके, मैं रिपीट कर रहा हूं फिर से. ओके, व्हेन द लो प्रायोरिटी प्रोसेस इन द क्रिटिकल सेक्शन, जब पीएलसीएस के अंदर है तो हाई प्रायोरिटी प्रोसेस आए तो क्या करूंगा? प्रायोरिटी इनहेरिटेंस प्रोटोकॉल अप्लाई करूंगा. तो इसका मतलब इसका प्रायोरिटी इसको इनहेरिट करूंगा, तो इसका मतलब इसको भी 20 करूंगा. 20 करने से क्या होगा? प्रायोरिटी ऑफ बोथ द प्रोसेस विल मैच. दोनों का प्रायोरिटी मैच होगा. दोनों का प्रायोरिटी मैच होता है तो क्या होगा? अराइवल टाइम के हिसाब से चलाते हैं अपन. सो पीएल और पीएच में कौन पहले आया? सो पीएल पहले आया था, तो इसका मतलब पीएल ओनली विल कंटिन्यू द एग्जीक्यूशन एंड पीएल विल कंफर्टेबली रिलीज द क्रिटिकल सेक्शन एंड लेटर हाई प्रायोरिटी प्रोसेस कैन कम इनटू क्रिटिकल सेक्शन. सो द सिंपल सॉल्यूशन, दिस इज अ प्रॉब्लम हियर and this problem is called as a live lock and solution to this problem is priority inheritance. Is that clear? So that is the priority inversion problem. So hope it is clear, right? So now understand here. So with this we completed software type of solution and hardware type of solution, and next we will enter into what? Operating system type of solution, that is a semaphore. So what is the meaning of semaphore and how semaphore will be implemented, and that is the important. So next we will continue with the semaphore. Thank you.